email you have to go to another so this one. Yes. Right. Yes. Right now it's SCI33205 M604. Okay. Meeting and finish. Right, finish. Okay. Sulapawin. Nothing more, right? Okay.ทุกคนได้ยินผมไหมครับหรือว่าไมค์ผมเจ๊งอะไรไหมเอ่ย
ได้ยินครับอาจารย์
ทุกคนได้ยินผมไหมครับ
ได้ยินครับอาจารย์ได้ยินพวกผมไหมอาจารย์
ได้ยินครับ
ผมมาจากผมอยู่ที่iPad นะครับก็ไม่รู้ว่า yes the microphone is out there right what about thisโอเคไหมครับlet me check usedโอเคทุกคนได้ยินผมไหมครับฮัลโหล not sure
ได้ยินครับ
อาจารย์ได้ยินไหมครับอาจารย์ฮัลโหลครับเทส1 2 3 1 2 3ครับฮัลโหลอาจารย์
โอเคยังครับไม่ได้ยินครับไม่ได้ยินครับwhat happened ไม่ก่อนฮัลโหลครับได้ยินกันไหมครับ
ได้ยินครับแต่อาจารย์ได้ยินผมบ้างครับ
ได้ยินแล้วครับได้ยินคุณแล้วครับได้ยินแล้วครับ โอเคครับโอเคso we have to continue yes okay let's continue our story วันนี้ไม่เช็คชื่อแบบกล้องนะครับตั้งแต่หลังเป็นต้นไปนะเพราะว่าเสียเวลาคุณนะครับมีคนบ่นนะครับแล้วก็ผมก็คิดว่าอย่างนั้นเช่นกันครับเพื่อให้ง่ายที่สุดครับกลับไปใช้วิธีเดิมของเรานะครับก็คือพิมพ์ชื่อมานะครับพิมพ์ชื่อในทางไหนดีทางแชทของ Zoom แล้วกันเนาะหรือว่าถ้าใครอยู่ที่ YouTube ก็ผมไม่ได้ส่งลิงก์ YouTube ให้นะครับถ้าใครอยู่ที่ YouTube ก็พิมพ์มาที่ YouTube ก็ได้นะครับโอเคทุกคนได้รับคะแนนนะครับถ้ามีข้อผิดพลาดสงสัยตรงไหนนะครับก็ให้รีบบอกผมนะครับสำหรับคนที่มีปัญหาคือเหมือนว่าการตะโกนหรือเปล่านะครับ
ครับเดี๋ยวผมส่งให้อันซ่อมพรุ่งนี้ครับ
ครับก็คุณครูเขารอเขาเรียกว่าอะไรรอรับงานคุณนะเพราะว่าเขาจะต้องแก้ไขให้คุณนะครับวันนี้ทุกคนได้รับเขาเรียกว่าอะไรทุกคนได้รับคะแนนทุกคนได้รับคะแนนคะแนนมิดเทอมครับก็ถ้าผมตรวจผิดพลาดยังไงขออภัยด้วยครับเพราะว่าไม่ได้หลับไม่ได้นอนครับช่วงนั้นสมองล้าๆครับwhat else this one and another one we can have 2 stream at the same time นะครับมี2 channel นะครับไลฟ์ของอีกเครื่องหนึ่งครับไมโครโฟนอีกตัวนะครับแล้วก็อันนี้ไลฟ์ที่ forward จาก Zoom ไปครับไลฟ์จาก YouTube สัญญาณมันอาจจะไม่ค่อยดีเท่าไหร่นะครับผมไม่รู้เพราะอะไรเดี๋ยวเปลี่ยนเน็ตให้เขาดีกว่าโอเคso let's continue our story you just write down your name in the same way as we have done at the beginning of the semester and please use the English word okay กันพลธนนัทนะครับพยายามเขียนเป็นภาษาอังกฤษเพราะว่าผมจะได้ดูง่ายๆคุณจะเขียนภาษาไทยคุณวงเล็บมาด้วยก็ได้เพื่อว่าบางทีคุณไม่ชอบที่ผมออกเสียงชื่อคุณไม่ถูกเนี่ยเพราะว่าผมอ่านจากภาษาอังกฤษเอาเนาะมันก็จะไปเป๊ะเหมือนภาษาไทย 100% ครับคุณวงเล็บมาแล้วกันครับถ้าอยากให้ผมออกเสียงชื่อคุณได้ถูกนะครับไม่ต้องเปิดกล้องแล้วนะครับเสียเวลานะครับเราว่ากันตรงนี้เลยนะครับกสิดิตโอเควันนี้
กระตุก
ที่ YouTube ใช่ไหมครับงั้นผมต้องเสียบอีกอันนึง
นบลืมปิดไมค์
ที่ซูมมีปัญหาไหมครับที่ซูมครับซูมมีปัญหาไหมเอ่ยis there any problem otherwise I'm going to use the SIM card okay it's 40 and what else chat you have one more message okay นะครับก็จะพิมพ์ชื่อเอานะครับเช็คชื่อคุณตามที่คุณพิมพ์นะครับ and then what else I need to
มึงต้องเช็คสเปลลิ่งด้วยเหรอ
share screen right
ไม่เห็นไหมเหรอ
everything here microphone
ฮัลโหลเพื่อน ใช่เหรอ
ตบไปมึงนบ
ทุกคนได้ยินผมนะครับแชร์หน้าจอให้อยู่นะครับ ไม่รู้ไปไหมเลยครับฮัลโหล Okay I hope that you can hear me right ทุกคนได้ยินเสียงเรียบร้อยนะครับได้ยินเสียงผมไหมครับ
ได้ยินครับอาจารย์
Can you hear me ได้ยินเสียงผมไหมครับ
ได้ยินครับ ได้ยินครับ
if not โอเคได้ยินนะครับโอเคพี่รันนะครับพี่รุนตอบมาแล้วโอเคthen we will talk about our story in the good note right now because the laptop is ready for you and then I think in M604 we arrive at the story about the force on current carrying conductor, right? And we arrive at somehow the formula. Oh no, I think yes. Did you arrive at the force equation in equation force formula in equation 33 ถึงตรงนี้แล้วใช่ไหมครับregarding the YouTube okay yes we arrive at somehow here right this is magnetic flux page 81 right no this is 67 okay we arrive at equation 33 in it's something about the force which is caused by the charge moving through a long straight copper wire or conductor, right? In when this one we don't need that at all. Okay. Yes. The total force is the summation of all n forces. Okay, the force that happens to each charge that is moving in the conductor, right? Yes. According to the last time before the midterm exam, we said that we have totally n number of charges, right? Which is this one, okay, the capital N. And so therefore we have n forces, and each force has the subscript a small letter of n here, and we make the summation in order to get the total amount of force, okay, that acts on that conductor. Well, assume that the force is controlled or followed by the force follows the superposition. Okay, you have the first force, you have the second force, so you have totally n forces, okay, that happens to this conductor. And of course we are using the basic idea from the former topic, which is for that acts on that acts on the chart, right, which is QVB, right? QVB sin theta, and we are going to use ผมรอsorry ผมอยู่ที่หน้าของเขาเรียกว่าอะไรใช่ขออภัยครับอัครวัฒน์ครับขออภัยครับไม่ต้องอัครวัฒน์ไม่ต้องเช็คชื่อแล้วนะครับคุณแค่พิมพ์ชื่อมาครับมันเสียเวลาครับโอเคผมอยู่ที่หน้าของ Good Note ครับมันจะไม่แจ้งครับใช่ไหมครับ so here we just follow the idea of the idea of
อาจารย์ครับได้ที่17มาแล้วครับอาจารย์ครับได้ที่17มาแล้วครับ
understand right the idea of force on each chart, right, is FQB sin theta, and according to the scenario there we assume that the angle is 90 degrees, so it's a right angle. In the total amount of chart is defined before, right? It's in equation 31. In the velocity is just the ratio between the distance per time, right, which is given by equation 30. And the scenario of movement was already explained to you previously in figure 32 and figure 33. Okay, we need to follow the second equality in equation 33, right? The total amount of charges or in charges, right, is the capital Q, and the velocity is from equation number 30, so it's L by delta T, right? And of course we are going to use the typical expression of current, okay, which is the movement of n charges, or simply speaking the capital Q, okay, per time, which is delta T. So we have in equation 33 the amount of total charge, which is Q, right? So you can see that Q from 32 is going to be Q equal I times delta T, right? You just move delta T to the left hand side, so you get the expression of capital Q. Okay, and that's why you get I delta T here in this scenario, in this equality. In L by delta T still remains there, okay, and what finally we can see is that you have both delta T at the numerator, okay, at the upper side, and the denominator as the lower side, right? So you can cancel them, okay, and the remaining thing will be only I, L, and B, right? And that's the result in the last equality in equation 33. Okay, if what happens if the angle between the magnetic field and the current movement is not right angle, okay, it can be any angle, okay, which is between 0 to 2 pi or 180 degrees. Okay, yes, the idea can be extended from the former expression, okay, and the idea is the following. In order to describe this, we change the angle variable from theta to phi, okay, on this page. The reason behind that is the following. I use the notation from two different books, so sometimes they use theta for the angle between the magnetic field and the current movement, right? So in this case, in the general case, here is the magnetic field vector, and the current just move along this way, right? And we get the direction of the current, okay, okay, the current is not vector quantity, okay, but together with the length L, okay, which is the length of the conductor, we can say it's vector L, okay. The size is followed by the size of the conductor, but the direction of this vector is going to be the same direction as the current movement. In of course, we can extend the result from equation 33, okay, if ILB as in this way, okay. B is the B right angle, okay, the perpendicular ผมอัครวัตรโอเคมีใครให้ผมต้องกดให้คุณเข้าอีกไหมครับมีไหมเอ่ย You are now 15 on the Zoom and here we have the results on 33, okay. The perpendicular magnetic field is the B with the subscript perpendicular notation, and we're gonna replace the B with perpendicular side by B side phi or B side theta, up to you, okay, because we have to consider the component that is perpendicular to the current movement vector, okay, or current direct movement direction, which is this way, right? And the significant or the important component is going to be this one, okay, which is 90 degrees with respect to the direction of the current. It's decomposed as B side phi, right? Okay, phi is the angle between the magnetic field and the current movement. And you may ask me, why don't we include the effect of the B parallel, okay? B parallel is the component projected onto the conductor, okay? We don't need to pay attention to or to take care of that, because this will be in the same way as the current movement, and from QVB side theta, when the angle between the magnetic field and the charge movement is 0, so it has nothing for us, right? It's meaningless for us. So we would the important thing for us is going to be only the perpendicular component, which is psi phi or psi theta, right? It depends on each server books, okay, or it depends on server books. So 34 is what we can, is where we can find the magnitude of the force. But in physics, we have another thing to pay attention, which is the direction, right? So in order to find the direction, is we're gonna use the same way, okay? Is you have seen before. F is Q and V cross B, right? Which is the velocity of the charge, velocity vector of the charge, and the magnetic field vector of that environment. But when we extend it to the long straight copper wire or conductor, we will have a new way, which is no longer QVB, okay? It's ILB, okay? With this expression, you can determine the force direction, okay? But if you want to find the magnitude, you just apply the 34, okay? This relation. Okay, that's again the cross product of the vectors. So let's practice ourselves to find the direction of the induced force in this scenario. Okay, please note that F is okay, F is I vector I sorry I, okay, I and L vector L cross B, right? The first vector you have to take care is the vector L, okay? You can see it's not vector. It's, yes, it's a scalar in this expression, but together with the current direction, we could say this is the vector L, okay? And Okay, this is the vector L and vector B is over there, right? You just use your right angle, you turn, rotate your four fingers from vector L to vector B, okay? Your thumb direction is gonna be pointing, it's gonna point upward like this, okay? And here is the way you apply the right angle, ตรงนี้พอเข้าใจนะครับจากเวกเตอร์ I ไปเวกเตอร์ B นะครับคุณหมุนมือขวานะครับ and next scenario if the angle between vector L and vector B is greater than 90 degrees what is going what will happen to us well we just use the same way okay B is I right and vector L cross vector B okay you just start from the vector I to the second vector, which is vector B. Okay, this is the vector L. You rotate your four fingers. From this one, your thumb direction is gonna be pointing downward like this. Okay, so that's why we get the output direction of the force of the induced force. Again, ILB. Okay, I is the current. Okay, but it's not meaningful for us in this expression, in this step, IL and then B. Okay. So you have ILB. You again, we need to start from the first vector, which is vector L, and we curve or we rotate our finger from vector L to vector B, right? Even it's pointing, even both vectors are pointing in the negative direction. For example, the magnetic field is pointing to the negative direction of the x-axis. The vector L is pointing in the negative part of the x-axis and the z-axis, okay, but it doesn't matter, okay, because the Cartesian coordinate is just the assumed configuration, but the reality for us or something meaningful for us is the quantity is related to physics, okay, which is L, B, and F. So L to B, we can use again our right hand and we get the thumb direction pointing upward like this, okay? Here is the scenario. We can determine again the force induced onto that long straight copper wire. So from the theory of force induced to the long straight copper wire, what happens to us if we don't have the long straight copper wire at all, okay? And most application or most scenario that take place in nature may not entails the long straight copper wire, okay? We may need to face with we have to face with the copper wire that is not exactly linear or straight, okay? And one application of that is the speaker, okay? We have the conductor, okay, wound into this core, okay, and we have the long straight copper wire, but we just rotate it, okay, along this core, and this core is placed around the permanent magnet, and we will see what happens if we let the current flowing from lower part to the upper part, okay? And this coil is called voice coil, okay? If you have a broken speaker, you can disassemble, okay, and disintegrate it, and you will see that there are 3 or 4 components. Okay, the first one is the paper cone. The second one is the watch cone. The third one is the permanent magnets. Okay, and it has the E shape. Okay, you can see this is the alphabet E in English. So we let the current, okay, pass through this conductor. Okay, it's gonna be like a solenoid actually around the paper cone, and the cross symbol means the tail or the rear side of the arrow, right? So the dot here is the head side of the current movement or the current flowing. Okay, so the current flow from the lower part to the upper part, but this is the cross-sectional view. Okay, it's you have the complete round around this cone. In they say the F vector is pointing to the left, and what is the reason behind that? มีคนพอนึกออกไหมครับว่าทำไมมัน F มันชี้ไปทางซ้ายครับ Okay, in reality, this shape of the paper cone, okay, will be attached to a frame of the speaker, and there will be a viscous material that leave this paper cone to the speaker frame, but the paper cone still can move easily. Okay, and it will return to the same position when there is no force. Okay, but when you have the current and there will be induced force, okay, the force will try to push the paper cone into the permanent magnets. Okay, it depends on how strong of the current. Okay, because as we have seen in 33 is the F equal ILB, right? And actually sine theta as well, but theta in this situation is 90 degrees, so it's gonna be number 1. Well, how could we determine, or how could we say the force direction is pointing to the left? Well, we can use, or we can apply the right hand rule again. Okay, let's consider or take a look at the upper part first. Okay, you can see that the current direction is out of the plane of the lecture notes. I don't know how to. Okay, let's switch to the camera and again on YouTube. In Zoom. Okay, let's talk about me. Okay, the force, the current is moving, okay, into this and to this limit, okay, to you. Okay, and the upper part of the watch coil has the current pointing to you, okay, in this direction to you. Okay, เดี๋ยวผมปรับกล้องก่อน okay, it's pointing to you like this, right? Where is here the camera? Okay, it's pointing to you, and the magnetic field is pointing. The magnetic field is pointing to the north to S, right? Let's take a look at the figure. Okay, as you know, the magnetic field line aside from the north pole to the south pole, right? It just run through the air or any empty material like this. Okay, it's when there is no spatial type of magnetic field, okay, no spatial shape, the magnetic field line just goes straight like this, okay, as the linear as the line, okay, as a straight line. And you have now the two vectors, right? The vector L, okay, which is in the same way as the current, and you have vector B, okay. Vector L, it's is in this direction, right? And vector L, to you, sorry. Vector L is in this direction, and the B vector, okay, is pointing upward. Okay, let's talk about the first part of the voice coil. Okay, the vector L is pointing in this way, okay, to you. Okay, and the vector B is pointing upward. So you can apply the right hand rule, okay, from L to B, right? You get the force induced in this direction, okay, to your left hand, okay, which is in the same way as the lecture notes. Okay, that's the upper part of the voice coil. But for the lower parts, the current is flowing into the plane, okay, in this direction, right? In this direction. So to me, right, in L, and but the B vector will start from the north pole to the south pole, okay. So because south pole, it's E letter, right? E shape of the magnetic permanent magnet. So the vector L, right, to the vector B, okay, you can apply L and B, right? You get the direction. Oh, sorry for that. You get the direction of the induced force in this way, okay. Again, to the left, okay, and that's why the total forces, okay, which is caused by two separate forces, okay, are pointing in the same way to the left. So that's why we get the results of the force pointing to the left like this, okay. So that's the reason. Sorry. And how strong is the force, okay, will depend on the strength of the force depends on this expression, okay. Depends on I, it depends on B, okay. And if you want if you want a very good speaker or sound, you should have the bigger paper cone, and in order to move the big paper cone effectively, you need to have more force, and in order to get more force, we have to insert more I, okay, current, or the B, okay, because L is fixed. And B, okay, so you can see that in the big speaker, they have very big permanent magnets. And if you want to get the sub bass subwoofer, a very low tone, okay, you need to insert more I, okay, and it consumes a lot of power, okay. And let's take a look at the first example we have here in slide number 90. It's the lightest bird, okay. It's, you may know that it's hummingbird, okay, but sometimes the people say it's a kind of bee. Yes, it's in the same size, the same scale as bee, so sometimes the people say it's bee hummingbird, okay. It's very small, it's tiny. What happened with this bird, okay? It's just stay on the long straight copper wire, okay, and they didn't talk, they didn't say about the magnetic field at all, okay, either in direction or magnitude, okay. They didn't talk about the magnitude, but they say that the mass of the bird is 1.6 gram, okay, which is very light, okay. It's a small animal. And the bar here, okay, is called perch, okay, and it's made of a kind of metal, so it can be considered as long straight copper wire for us, because they let the current from flow from the left side to the right side. Okay, the vector direction for the L is going to be pointing like this, but they say that they want to design this system, okay, so that the bird, okay, the bee hummingbird standing onto this bar or perch, and then they can it can stay like this, okay, without any falling down effects. So what could we do? Okay, so in order to get this the answer for this problem, okay, the question is, what is the magnetic field? What should the magnetic field be in this scenario? Okay, that's the question. Well, of course, you know that every particle, every matter should have the mass, right? And the mass of the perch, okay, the perch is not considered to be zero weight, okay, or weightless, but it has also its own weight, which is its own mass, okay, it's 7 grams, and okay, it's even heavier than the bird, okay, and so you can see that the total mass, okay, which is the force, okay, attracted to the center of the earth is the summation between these two quantities, 1.6 and 7.0, okay, it's going to be 8.6 gram totally. So the designer would like to have this set up, okay, in equilibrium, okay, the perch and the bird will not fall down. So the question is, what should the magnetic field be in this scenario? So you can see that this is the, in order to analyze this thing, you can see that there is the weight, okay, that's the first force, okay, caused by the attraction by the earth, and we need to have the magnetic field pointing upward, okay, so that everything will be in equilibrium, okay. The upper force should be equal to the lower force, okay, simply speaking. And yes, we have to apply the IRB expression. We are gonna solve it on the next page to you, okay. Of course, you have let's draw the free body diagram. This is the mass, okay, mass of any object. It's mass 1 plus mass 2, okay, which is the mass of the birds and the mass of the perch, okay, together. And of course, there will be downward force, which is the weight, okay, and the upper force should be the force that can maintain this object, okay, to stay in equilibrium. So this is the FB or F magnetic, as you like, okay, they say FB, okay. So and of course we know that the weight of this system, okay, including both the bird and the perch, will be the mass of the birds, okay, plus the mass of the perch, right, and times c, right, and that's the first force, okay, which is caused by the attraction to the earth, right. And for us, we have to determine what is no, sorry, we have to determine what is B in this scenario. What is B in this scenario, and what is its direction as well, okay. What is vector B? Okay, totally, simply speaking, including both the direction and the magnitude. Well, in order to get the upper force, okay, the force pointing upward, you need to have the L vector. I don't know, the B vector, right? This is the L vector, right? And you should have any direction of vector B so that you can get the force, induced force upward, okay, pointing upwards. So L, but from the basic formula, B is I L cross B, right? So sorry, it's F. Stupid. Okay, in order to get the force pointing upward, we have to start from the first vector, okay, L, and L is in this direction to the left, right? And what about B? What direction of B do you think, so that we can get the force pointing upward? คุณคิดว่า ID pass need to นีลูล่านี่คือใครครับ เป็นฝรั่งหรือใครอ่ะ I don't know him. ไม่ใช่เราในห้อง604ใช่ไหมครับเขามาพิมพ์ใน YouTube คืออะไรอ่ะต้องการเข้าไม่รู้เรื่องไม่เกี่ยวด้วย Okay, I don't care. Okay, what direction of the magnetic field should we have in this scenario so that we can get the force pointing upward? What do you think? Okay, you have to consider making use of your right hand, right? ยังไงดีมันต้องเป็นทิศของเวกเตอร์ b ครับต้องเป็นอะไรดีมันถึงจะได้ทิศของแรงชี้ขึ้นโอเคไหมครับ The first thing is that if your b is pointing like this, okay, the outcome of the induced force to you is gonna be downward, right? Fb should be in this way, right? But it's not. It doesn't satisfy our requirements, okay, because we want the induced force pointing upward, okay, according to this figure, okay, that's the force we would like to have, right? So let's take a look at another direction of the possible magnetic field, okay, if we say ไม่รู้ผมใช้สีเหลืองคุณจะเห็นไหมครับผมว่ารูปสีเหลืองคุณเห็นไหมไม่ได้เรื่องเนาะงั้นไม่เอาดีกว่าไม่เอาสีเหลืองครับokay, let's say this is another direction of possible magnetic field, okay, another possible direction of the magnetic field, and then we are going to consider the use of right hand, okay. Let's say if this is our right hand and we rotate our fingers from L to B, and of course it satisfies our need right now, because now we get the force pointing upward like this, okay, and that's great, okay. And yeah, we can say that B should point pointing into the plane, right? The directional plane, okay, into the paper, okay, and that's the first answer we can deliver right now. And let's talk about the magnitude. What about magnitude of the magnetic field should we have? So what is B? actually. Okay, so in order to determine or find the value of b, so you need to apply the, I don't think it's the first law in the first Newton law, right? We would say that FB, okay, which is pointing in the opposite direction to the weight, okay, should be E equal to the weight of the whole system, okay, so that everything will stay in equilibrium. Well, that's the basic fundamental, right? You get from former courses in physics. And of course, on the left hand side, we're going to have the magnitude expression of the ILB, right? Of the current and the length of the conductor and the strength of the magnetic field. Okay, you can say it's ILB sine theta as well. It's up to you, but okay, and you can say it's the magnetic field doesn't need to pointing with the right angle to the current movement. Okay, it's also possible. It's up to you. But let's say we consider the spatial case. Okay, the simplest case when psi contains 90 degrees. Okay, and weight of both objects, which is the mass of the berth and the mass of the perch or the bar, right? In time c, right? And of course, this one is gonna be oh, what happened? Sorry for that. Oh no, sorry for that. อะไรไม่รู้ครับโทรมาครับโอ้ทำให้อันนี้ผมเสียไปด้วย it's number 2 right 316 okay, you know that sine theta, sine of 90 degree is going to beนะครับขออนุญาตเข้าอีกคนนึงนะครับเพื่อว่าจะได้เช็คนะครับ you know that sine of 90 degree is equal to number 1, right? Is that all right? Okay, no. Oh, no microphone at all. Okay, no microphone. Yeah, this one is equal to number 1, so it's meaningless to us right now. In we want to find the value of b, right? So we have here b, okay, and we move the first two terms, which is I L, to the right hand side, right? So we get b equal m mass of the burst plus mass of the perch, okay, times the acceleration on Earth, right? 9.8 meter per second square. And I and L will appear here at the lower side of the denominator position to this ratio, right? So let's substitute the value of each component into that expression. Inverse 1.6 gram, 1.6 plus the mass of the perch is even greater than that. It's 7.0, right? And you're gonna have the, oh, let me see it on the Google Note. Oh, sorry. ครับขอใช้ Google Note อีกเครื่องนะครับเป็นตัวช่วยครับ it's Untitled can't fetch done. Sky problem. Okay. 1.6 plus 0.7, right? It's 0.7. No. One point six plus 0.7, right? Yes, it's, but the unit here is in terms of gram, right? So we have to multiply it with 10 raised to the negative 3, right? To convert it to the kilogram scale, right? And G, what about G? G is the 9.8, or you can simply say 10, okay? In meter per second square, right? And that's it. And the current to this scenario is given there, right? I don't know. Okay, they say the current is flowing at that moment as 4 ampere. So we would say this is 4 ampere, right? Okay, and that's the first component. The second one is the length of the conductor. So the length of the conductor is 10 centimeters. Okay, so we can say it's 10 centimeter, but we have to convert it to meter. It should be times 10 raised to the negative 2, right? So now it's written in the standard scale, which is meter. So let's go to the next slide ครับคุณก็เอาไปใส่ในเครื่องคิดเลขนะครับ Okay, so let's put it into the calculator. It's what is that? This one, right? SCI. What is that? It's 1.6 plus 7.0 and times 10 raised to the negative 3, right? And times 9.8, right? That's the acceleration on Earth, and divided by okay, let's say this is the B, right? The magnetic field, okay, B. And the denominator includes 4 times 10 times 10 raised to the negative 2, right? นะครับบางคนมีทำมาสมบูรณ์นะแต่ว่าคิดเลขพลาดนะครับ Okay, so let's generate now later. Okay, let's see the value of the magnetic field. So it's ไม่รู้คุณเห็นเลขอะไรนะครับ Can you see it? ไม่รู้ผมปรับให้มันใหญ่ๆได้ไหม but แต่ว่าคุณเห็นใช่ไหมครับตัวหน้าจอนะครับคุณเห็นไหมเอ่ยคุณเห็นนะ it's equal to in YouTube is something like the media cycle. Yeah, definitely. Okay. Yep. Oh no. Oh yeah. This one. Okay. Yeah, that's the magnetic field. Okay, the magnitude of the magnetic field we should get. So let's get back to so it's ตอนไหนนะตะกี้นี้โอ้มันอยู่คนละหน้าผมย้ายมาอยู่หน้าเดียวกัน Okay, right. 2107. Okay, 0.2107. So because we have manipulate everything in to the standard scale of the unit, right? So the unit will emerge as the Tesla as well, right? It's Tesla, so it's 0.2107, right? Is the result here? Okay, equation number 37. Okay, all right. And now let's get into the next example. เวลาบ้างครับอ๋อได้อยู่นะครับ Okay, let's get into the next example. Oh no, it's not online, but no, this thing, this one, right? And I know which one is better. Okay. Yep. มันไม่ใช่หน้าเดียวกันwhich one 4K เดี๋ยวนะครับทำไมมันไม่ใช่หน้านี้นะครับที่ออกนะครับno. Okay, I hope but it's not correct, right? เดี๋ยวนะครับที่ YouTube จะให้ออกให้มันเหมือนกันครับ I hope this one, right? Here we have another example. Y carries a current of 22 amperes, right, from west to east, where they didn't provide the figure at all, but no problem. The current is moving from west to east, okay, in a copper wire. Assume that the magnetic field on Earth, okay, of the Earth at this location is horizontal and directed from south to north, okay. So if we draw the figure in 2D, okay, it's going to, the current is flowing from left to right, okay, with the amount of 22 ampere andแป๊บนึงครับผมขี้เกียจหมุนตรงนี้นะครับ okay, we're gonna use this one instead of that. Okay, and yes, okay, the magnetic field is directed from south to north, okay, so the magnetic field is going to be in this way. We use the green one, okay. B is this way, okay, like this. All right, แล้วมันทำไมไม่อัปเดตนะที่คอมพิวเตอร์ครับ Okay, so they asked us about the magnitude and direction of the magnetic force induced onto the cable of 36 meter. Oh, it's a big scale actually. So they say that the size of the conductor here is 36 meter. Okay, it's quite large. Okay, so what do you think? This is the B vector. Okay, and okay, the current will give direction to the length of the copper wire, right? So this one will represent the vector L. Okay, yeah, it's vector L. So totally you have vector L like this. That's the vector L, and the vector B is somehow like this. Okay, so what is the direction of the induced force in this scenario? What do you think? นะครับทิศทางของแรงที่เหนี่ยวนำจะต้องเป็นอย่างไรครับโอเค so of course we can apply the right hand rule from the formula I L cross B right. Okay, we start from the first vector, the vector L to the vector B. Okay, you curl or rotate your four fingers from L to B, right? But this is the east part, right? Like ประมาณว่าอุบลราชธานี okay ไหม and here is to the north, right? เชียงใหม่เชียงรายนะครับ okay ไหม if we look at the map of Thailand, okay, to the country L to B, right? So what do you think? What about the reduce the direction of the force if you apply or you just use your right hand คิดว่ามันจะเป็นยังไงครับทิศไหนดีทิศของแรงครับ What do you think thenไม่ลงมาof course you can see that the time direction will give direction of the induced force, right? It's going to be the point will be directed out of this page, okay, out of this lecture, out of this plane. So the force is pointing to us, okay, to the reader, to this page. And the first question is find the magnitude and direction, okay. We can say that the direction will be out, okay, out of this plane, okay, this lecture note. And what about the magnitude to this one? We have to apply the typical formula, which is F equal ILB sine theta, right? Okay, we have to apply the ILB sine theta so that we can แล้วทำไมเขาไม่ซิงค์กันครับใช้คนละ Wi-Fi กันนะเครื่องนี้เดี๋ยวแป๊บนึงนะครับ let me check the Wi-Fi is already correct in this one. You also use the same but 5G. No, you have to use the same router, which is this one. No. No. This one. Okay. ILB. So for ILB sine theta. Okay, LB sine theta or phi up to you. Okay, in of course when once we get this thing, you just substitute all values to that. Of course, I is 22 ampere, right? It's 22 ampere, and L is the 36 meter. Okay, and the B, which is the magnetic field, it's 0.5. Okay, it's not so strong. It's 0.5 times 10 raised to -4 Tesla. And what about sine theta? The angle between the conductor and the magnetic field. You can see that here is theta is 90 degrees, right? So it will give you psi by number one. So we don't need to write down the expression of psi at all. So we put everything into the calculator. So it's 22, right? F equal this one is meaningless to us. Is F is no. F is 22, 36, right? Here is 22 times 36 times ALB, right? 0.5 E minus 4, and sine theta is number 1, so we don't need to take care of that at all. Generate. So F is 0.396, okay, 0.396 approximately. 0.396 unit is of course Newton, right? Because we have prepared everything into the normal scale. Let's see the 0.396. Zero as well, zero in front of that. Okay. 0.396, and that is for the magnitude to the magnetic field. So they asked us also another question, which is calculate the gravitational force on the same length of the wire when it is made of copper and the density of the copper is rho like that, and the cross-sectional area of the copper wire is like that. So let's get into this problem. The gravitational force, right? So we have the copper wire like this, right? เวลานะครับจากกฎนะครับเขาบอกว่าผมต้องปล่อยให้คุณเลิกเบรกก่อน20 นาทีใช่ไหมครับฮัลโหลครับ
ครับผมอาจารย์ครับผมอาจารย์ครับหมดเวลาครับ
อยู่เนี่ยมีใครพูดสักคนหนึ่งได้ไหมครับทำไมผมไม่ได้ยินคุณเลย
ผมพูดอยู่ครับ
ปล่อยก่อน20 นาทีครับอาจารย์ก่อน20
เขาให้คุณพัก20 นาทีนะคือจริงๆต้องก็2 ครั้งก็20 นาทีใช่ป่ะเพราะคาบหนึ่งของผมชนกัน2 ครั้งครับก็14แล้วผมก็ต้องให้คุณเบรกนะเพราะว่าตามกฎของเรียนครับไม่ใช่ว่าผมไม่อยากสอนนะผมอยากไปต่อเรื่อยๆนะกำลังมันเลยนะจะหาเวทให้คุณนะครับ so I need to leave you like this, okay? We need to quit the lecture right now so that you can take a break or for 20 minutes. I'm not sure whether it's correct or not, but what I heard is 10 or 20 like that. But for me, we are two periods together consecutively. So today is Wednesday, so we will have the homework for Friday. Okay, next 2 days. Okay. If you have any questions, just let me know. Okay. If not, then see you. Bye bye ครับ สวัสดีครับ We are only 7 people. Okay.